Hey everybody! Today's lesson is called the converse of the Pythagorean theorem, or in other words, is it a right triangle? So, the converse, alright, so what does that actually mean? It's kind of like the opposite. So we know that the Pythagorean theorem says one leg squared plus the other leg squared equals the hypotenuse squared. And that's true for every right triangle, any that you could draw. Well, the converse is true, meaning, let's say we have a triangle and we want to know, is it a right triangle? Well, in order for it to be a right triangle, then one leg squared plus the other leg squared has to equal the hypotenuse. Well, a little caveat there, we didn't say it in the last lesson, but also what's true is that the hypotenuse in a right triangle is always the longest side, every time. The hypotenuse is always the longest side of a right triangle. So how can I go about determining whether or not I have a right triangle? So if you look right here, okay, and this just kind of sums up what I said. You're going to use the Pythagorean theorem, and then remember, and let's actually highlight this bullet point. Remember, the hypotenuse is always going to be the longest side. If the numbers work in the Pythagorean theorem, then it's a right triangle. And if the numbers don't work, then it's not a right triangle. And most important, just because a triangle looks like a right triangle does not mean that it is. Remember that a right triangle is one that has a right angle. Right angles measure exactly 90 degrees. Is your eye good enough at determining whether that if this angle is right angle? It could measure 89.9 degrees, which would mean it is not a right triangle, but it might look like a right triangle to our eye. So we can't just look at it and assume it's a right triangle. All right, so let's go through an example. It says, is the triangle below, I should say to the right, meaning is this triangle a right triangle? Well, step one, label the proposed legs and hypotenuse. So if it's a right triangle, then the hypotenuse would have to be the side that's labeled 10 centimeters. How do I know? Because the hypotenuse is always the longest side. So that would have to be the hypotenuse, meaning the other two sides would have to be legs. Okay, so we've done number one. Check. Number two, substitute the numbers into the Pythagorean theorem. We're going to put a question mark on top of the equal sign because we don't know if it's going to be a true equation or not. So first, I'm going to write my Pythagorean theorem. A squared plus b squared does equal c squared. No question mark there. We know that's a fact. So a and b, remember we said represent the legs. If this is a right triangle, then 4 and 7 are the legs. So 4 squared plus 7 squared. Does that equal, so a question mark on top of my equals, does it equal 10 squared? Okay, so let's go ahead and square everything. Well, 4 squared is 16. 7 squared is 49. Does that equal, well, 10 squared is 100. So we're going to add 16 and 49, and that is 65. Which does not equal 100. So I put the line through, okay? So we've done step 2. We actually did step 3 also. It says evaluate each side until there's only one number on each side. So we've done that. Number 4, if the numbers are equal, then it's a right triangle. Meaning, if 65 was equal to 100, it's obviously not. Then it would be a right triangle. If the numbers are not, then we say not a right triangle. So I'm going to write up here, not a right triangle. That's the answer. You have to have this work 100%. Okay, let's go to example 2. So is a triangle with sides 12, 20, and 16 centimeters a right triangle? All right, so they didn't draw this out. They just gave us side lengths. Which one of those would have to be your hypotenuse? 20, because that is the longest side. So the 20 would have to be the C value or hypotenuse. So 12 and 16 would be my legs, my A and my B. So we're going to write that in. We're going to write down our Pythagorean theorem. A squared plus B squared equals C squared. So A I've got labeled as 12, plus B I have labeled as 16, and C, question mark over the equals, I have labeled as 20. So I'm trying to see, is 12 squared plus 16 squared, is it equal to 20 squared? If you put the 20 in any other spot other than where it is, then this isn't going to work out for you. The 20 can only be the length of the hypotenuse if it is indeed a right triangle, because the hypotenuse is always the longest side. All right, so we're going to square everything, right? 12 squared, remember, means 12 times 12, so that's 144. 16 squared is 256. Does that equal 20 squared? And 20 squared will be 400. So I'm doing 256 plus 144, and I get 400. And on this side I have 400. I'm going to put a check mark. So both sides are equal. So do we have a right triangle? Yes. A triangle with sides of 12, 20, and 16 would be a right triangle. Yes, it is a right triangle. And we're going to go ahead and highlight that because that's our final answer. All right, let's go to the next page. On the next page, you have some practice problems. And it says, determine if each triangle below is a right triangle. Show all of your work. So notice sometimes you are given a right triangle, and sometimes you're just given side lengths. So problems 1 through 3 have drawn in triangles. Do not automatically assume it is a right triangle. It may not be. It may be close to a right triangle. All right, so I want you to go ahead and do 1 through 6. So pause the video and do 1 through 6 now. And remember, you should be showing your work for each problem. Pause it, then come back. We'll check. Okay, everybody, welcome back. So you need to check over your answers to each of these problems. You should have shown your work just as you've seen that I have shown my work. And you should have written whether or not this was a right triangle. So either yes it is or no it is not a right triangle. So that should be your final answer. It's also very important that you've labeled the proposed legs and hypotenuse for each one of these scenarios. Okay, so here's problems 1 and 4. So pause the video and get that information down and make any corrections if you need to. Okay. Problems 2 and 5. And before we move on from number 5, just remember that when you are squaring a square root, you just end up with the number without the radical, right? So remember that. So there's 2 and 5. You've already gotten those. And 3 and 6. Okay, so hopefully you've done well with this. If you have questions about anything, please bring them to my attention so that I can assist you. All right, go ahead, turn this in, and work on your independent practice.